Hi, I'm Rajiv. Welcome to OpenHWare Learn and Teach. This is our first course on OpenHWare, and this course deals with Introduction to Microcontroller Programming. In this course, we'll be learning about microcontrollers in some detail, how to use it, how to program it, and so on. In this first video on this lecture series, I'll be telling you what a microcontroller is. This lecture will especially be beneficial for those who are new to the microcontroller world. After seeing this video, you'll be able to conceptualize about a microcontroller. You'll be able to have some idea about what a microcontroller is. But before we start, let me tell you, often in this video series, I'll be using mu-c for microcontroller. This mu being used for the word micro. Okay, so let's begin. A microcontroller is very similar to a computer. I'm sure you must have all seen and used a computer before. Let me draw a rough sketch of a computer here. This is your monitor, computer monitor. This is an old traditional desktop type computer. This is your keyboard. Not very good in drawing, so you have to use a bit of your imagination here. This is your CPU with some slots in them, and most computers now also have a mouse. Okay, let me label these. So this is your CPU, this is your monitor, this is your keyboard, and this is your mouse. Now, what is the most important part of this whole setup? What is the most important part of a computer? The most important part of a computer is this CPU, which is also called the brain of the computer. Why is it called the brain of the computer? Because it houses the most important part in a computer, which is its processor. Okay. This processor performs all the arithmetic and logical functions in a computer. Means all the calculations, all the algorithms that have to be performed are performed here in the processor. In addition, your CPU also contains some other features, some other things like memory in the form of RAM and ROM. I'm sure you're familiar with these terms before. And also has some other peripherals. Your CPU has also some other peripherals. So all this plays the most important part in a computer. That's why the CPU is called the brain of the computer. And to this CPU, you can connect other input and output devices. For example, keyboard is an input device. You can connect it to your CPU. So once you connect a keyboard to the CPU, all the keyboard presses, all the key presses can be detected by your computer. You can connect other input devices like mouse. Mouse is an input device. Once you connect a mouse to your CPU, it can detect left click, right click, scroll, and so on. You can also connect output devices to your CPU, like a monitor. Once you connect a monitor to your computer, you can display whatever you want on this monitor. Okay, so you can connect other output devices like printer to the CPU. You can connect other input devices like joysticks and so on. So these are your input device which you can connect, and this is your output device. Okay. Now, a microcontroller is very similar to a computer. A microcontroller is basically a small IC chip, which is also called a chip. Okay, so this is your microcontroller chip or an IC. Okay, the number of pins in this IC can vary from anywhere starting from 8 pins to more than 40 pins. Okay, and the microcontroller is very similar to a computer. It also has a processor inside it which can perform arithmetic and logical functions. It also has some memory element inside it in the form of RAM and ROM, very similar to what we saw in the computer. It also has other peripherals inside it, which we will be talking about later in our course of study. Other peripherals. What is most important, you can also connect input devices to your microcontroller, and you can also connect output devices to your microcontroller. Okay, you can connect input devices like sensors, let's say a temperature sensor or a humidity sensor or a fire sensor, smoke sensor, and so on. You connect output devices like motors, LEDs, and so on. Motors, LEDs, and so on. Okay, so as you can see, uh, microcontroller is very similar to what we saw in the computer before. So what's the difference between them? What's the difference? What's the difference between them? The difference is a computer. This computer can perform several functions inside them. For example, right now I'm using a computer and I'm using this MyPaint software for sketching this uh, this lecture. At the same time, I have in my computer I have a VLC stream running going on, which is recording my desktop. And at the same time, I have an Audacity software running, which is recording my voice. So all these different functions, you see, this is related to video processing. This is related to sound processing. This is related to this software is related for graphics. All these are different works that can be done in a computer. In addition to this, you can do several things in the computer. You can draw. You can use a browser. Uh, you see, there is time getting displayed here in a computer. So all these are happening at the same time. On the other hand, in a microcontrollers, everything is very limited in size, very limited in capability. The processor is limited in capability. The memory is limited in capability, and other peripherals are also limited in their sizes and capability. So a microcontroller can perform very small and dedicated tasks. Small dedicated tasks. What do you mean by small and dedicated tasks? That means it means it can only perform one type of task, one type of function, all the time. Okay. Uh, I like to give an example where a microcontroller is used. Uh, I'll just give an example. Uh, you must have seen a digital watch. I'm just drawing a rough sketch of a digital watch, which displays your time in digits. Those kind of watches run using a microcontroller, and the microcontroller has got only one task, just to keep record of the time. That's all. It doesn't need to do video processing. It doesn't need to do audio processing. So only one type of task is run by this microcontroller. And these kind of places are where microcontrollers are used to perform only one small dedicated tasks. Because the size of their processor, because the size of their memory, because the size of their other peripherals are limited. Similarly, microcontrollers are nowadays used in almost all types of devices. Your refrigerators, your fridges, almost anything that you can think of, remote controls, all of these things run a microcontroller. I hope you can abstractly conceptualize our microcontroller now. That was the purpose of this video. And in the next video, we'll be continuing with this lecture series, and our next video will concentrate on to take a peek inside a microcontroller to see what is inside the microcontroller. How does it work? Okay, so this lecture series will be continued again. Thank you for your time.